Hello class. Now, I ask you a simple question. What is a function? Now, let us describe an input space, and let's call it I. And let us define an output space, and let's call it U. And U doesn't stand for anything. It's just very weird to speak of O when, using certain set convention, therefore we use U. And by the way, why it feels weird is because O can be, mistaken as an empty set, which it clearly isn't. So, there's that parallel. So I and U. Now let us define some elements of I. Let's say A, B, C, and D. And then let's define some elements of U. Let's say alpha, let's say beta, let's say, like omega, and so on. Now, what a function is, and what a function is defined as, is a relation relating a set of inputs to a set of outputs. So, a function will link each element in set I to each element, or well, not each, but like that stuff doesn't matter in this video. Like for our intents and purposes, each element to U. For example, A will connect to beta, B will connect to alpha, and C and D will, let's say, connect to omega. Now, and this is a function. This relation is defined as a function of I. And we denote it as function of I gives you the set of U. So, what is an inverse function? Now, an inverse function basically asks the question, I have an output in the U space. What element in I space led to the element in the U space? So, the inverse of f of x, f of I, will be defined as f of inverse U will lead, not like this, U will lead to I. So this is the relation of a function and an inverse function. So for example, f of inverse of alpha will be equal to B. And f of inverse of, let's say, beta will equal to A. And so on. So we will define an exponential function a of x. F of x is equal to a of x. This means that you have all values of x here, all the real numbers, and they will lead to themselves raised to the power of a. For example, 2 will lead to a squared, and so on. So, I will define f of inverse of x as the logarithm base a of x. So I'm defining the logarithm as the inverse of a of x. So the logarithm basically asks the question, what value raised to the power of a gives you x, which is the inverse of the question possessed by the a of x, the exponential function. So we have some rules because it's mathematics, so of course we do. Now, a can't be equal to 1. Why? Well, it doesn't make sense that it would. I mean, look at it. 1 to the x is always 1, so it's a useless function. Why would we use it? Why would we need it? A has to be bigger than 0. Now, why it has to not equal 0? Well, it's the same answer for why it needs to be not equal to 1. Well, if it is equal to 0, it's a useless function, because 0 to the power of anything will be equal to 0, and it is actually worse than 1, because 1 to the 1 or 1 to the 0 is at least defined. I mean, 0 to the power of 0 isn't even defined, so you just have a non-continuous function just sitting around, a constant function. It's useless. So why does it have to be bigger than 0? Like, why can't it be negative? Because then it will be lead to imaginary numbers in the output space. And there's actually nothing wrong with that. It's just, I don't actually know why we don't use imaginary numbers. It just complicates things, I guess. But we can use imaginary spaces and just define a to be just not equal to 0 or 1, but it can be negative if we are using imaginary spaces, but we're not in at least this course. Therefore, we say that it is undefined. So yeah, that's the thing. And in the logarithm case, by the way, this a is the same a as this, so everything applies. X has to be bigger than 0. Why? Now, you know how logarithm base a to the x basically responds to the answer, what value raised to the power of a gives you x? Well, assume x is 0 for a minute. 0. Now, and this is y. Let's say this is y. So, a of y is equal to 0. How can that be? Like, how can that actually be? Well, it can be if y is minus infinity, but we don't really mention infinities as real things because you can only approach infinity, you cannot be infinite. So it can obviously not be 0, and it can't be negative because a positive value raised to the power of anything basically is a positive value. I will show this in greater detail when we go to the graphs of logarithms, so be sure to remind me on that. Anyways, thank you for watching. This is Logarithm. Goodbye.